Welcome to, I guess this is part two of these log kind of properties that you have. So in part one, I basically went over these properties that you have, and if you want to see where they come from, so I'll put up a link up above there. And I'm going to use, I guess, maybe some of them to try to show the rest of the properties. Now, these properties of logs actually are kind of useful to be able to use in various different applications. In particular, property number 4 that you see there, where you're changing the base of a log, is extremely useful because on calculators, most of the time, what we have is the log just for base 10. We don't really have an option for any base that we like. So using that property number 4 is super useful, and maybe I'll show you a little brief example at the end. Now, coming back to these, when you're talking about logs, you should be aware that what they come from is basically the inverse of the exponent. And these two statements are equivalent. So y is equal to b to the x, or if you're trying to search for the exponent is equal to log of base b of y. And you can rewrite these back and forth to for any convenience that you want. So I want to show you that if you take these first 4 properties, I'm going to take the first one, and I'm going to show you why this one holds. Now, if you don't really care about, why or where they actually come from, so kind of proving them, then obviously you can skip them and you can use it. But I do hope that, if you're kind of maybe in grade 11 or maybe finishing up high school, you should know where these properties are coming from. And here is the property number 1 that I'm going to try to show you. So what this property says is if you have a base, so in this case our base is b, so notice the base b is the same for all of them. And now you're trying to take the log of two numbers that are multiplied by each other. So in this case it's m and n. Then the property states that the multiplication of the two is actually just taking the log of the individual numbers and then adding them together. You might recall that this is kind of goes hand in hand with exponent rules, right? When you are multiplying, you are going to be adding up the exponent. So you can think of it kind of in a similar fashion here. So where does this come from and why is this true? So what I'm going to do is I'm going to take this log of b to the m, and I'm going to call this, let's say, x1. And I'm going to take this log of b to the n, so n for Nancy, and I'm going to call this x2. Now, if that's true, okay, then I also know, okay, so if I have this right here, which basically states x1 is equal to log of base b to the m, then I can also rewrite this by our equivalence, which we have right here. So changing from log back into the exponent form. So I can rewrite this and say that m is equal to the base b to the exponent of x1. And I can do the same thing for this right here and rewrite this as simply saying n is equal to the base b to the exponent x2. Now, what I'm going to do is I'm going to take this m and I'm going to take this n, and I'm going to substitute it back into here to show you that they're actually equivalent, okay? So that this statement is true. Now, if I do that, so if I take m and I multiply it by n, so notice that equals 2. So I'm just taking it from this line right here. So that's going to be b to the x1 multiplied by b to the x2. Now, of course, utilizing our exponent rules, because we have the same base b, then this is nothing else but simply saying b is raised to the exponent of x1 plus x2. So that's what this equals. So that is my m multiplied by n. So this is what it will equal. Now I can take this and I'm going to substitute it back into here. Okay, so I'm going to substitute it back into here because I have m multiplied by n. But what happens if I do that? Then I'm going to have log of b, and then in brackets, this is going to be b x1 plus x2 in this particular case. And from here, what I notice is I have a b, okay, and then inside, okay, I have a b to some exponent x1 plus x2. But hold on a second. That is exactly the property that I have right here. So you have log of some base b, okay, inside b to the k is just equal to k, just to the exponent. Well, my exponent in this case, so all of this, is going to be just equal to x1 plus x2. But this is exactly how I defined, so notice you get log of base b m plus log of base b n, which is exactly our statement there. Now, if you were able to follow that, then a huge thumbs up to you. And if you weren't able, I do encourage you to try to step yourself through this and then see, the trick that I used right here, and then just changed it back to exponents, okay, to try to see how this actually worked out. So that's the proof of the first property. Now let's take a look at the second property and see if we can do something which is of similar fashion. Now in this case, I will be using, so I'm going to copy this, I'll be using exactly the same type of trick, because now what I have is I have division right here, m divided by n, and notice the subtraction, and this again kind of brings you back, or should bring you back, to exponent rules. When you are dividing, you subtract the exponents. Now we're taking the inverse, so we're working with logs here, but it might be easier to help you to try to remember that. So when you divide two numbers, okay, it's the same thing as taking the subtraction of the logs of the individual numbers that you have, in this case m and n. I'm going to do exactly the same thing. So what I'm going to say is let this be x1, and then what I'm going to say here is I'm going to say let this be x2, and I'm going to play the same trick. So from there, I do know that I have m is equal to b to the x1, and here I have n is equal to b to the x2. Now taking these, so m and n, and then substituting it back into right there. So what I will find is I'm going to have, okay, and I'm going to write it actually out in full. So notice log of b, and I'm going to substitute it inside. My m, okay, is b x to the 1 divided by my b x to the 2. But hey, hold on, wait a minute. This, okay, inside of our bracket right there, I have the same base. So that means I can subtract my exponents, and this will just be log of base b of b to the x1 minus x2 because of the division. And once again, I run into this great property, right here, where I can use that, where log of base to the base and then exponent k is just equal to the exponent. So what I have there, this will simply equal to now x1 minus x2, which, okay, as we know, we defined it as log of bm minus log of bn. And there you have it. That's exactly what it's supposed to equal. So the left-hand side equals that right-hand side. So that's the trick that you can use. Now, let's take a look at property number 3. So in this property, so it's a very neat property that we do use. I'm going to copy this, and I'm going to bring it down right here. So how would we prove this one? Now, for this one, I'm going to use something a little bit different. I'm not going to use the definition of setting something to x1 or x2. And Instead, what I'm going to use is I'm just going to use the knowledge of what this exponent actually means right here to show you that I'm going to get the right-hand side. So please remember, so this one is actually not as bad, so log b. Now, what does m to the n mean? It means your number m, so for Mary, is raised to the exponent of n, okay, Nancy, and you're doing it n times. So I'm going to have really what I have is m multiplied by m multiplied by, m, so on. How many times? How many times am I multiplying? I am multiplying this n times because that was the exponent. But if that is true, I can now actually use the property I just proved. And the property that I just proved, okay, I'm going to go right above here. Okay, so right here, property number 1, so this one. What this property tells me that if you multiply two numbers together, it's like taking the log of the individual numbers and then adding them up. And so in this case, my numbers are the same. So right here, so notice I am multiplying numbers, okay, together. Now it turns out that the numbers are the same, the number m for Mary. And what that means is from that first property that this really means log b of the individual numbers when they're supposed to be all added up together. So I'm going to be doing this, so plus dot dot dot. So I have to do this. How many times? This is going to be n times, which was the actual exponent. But hold on a second. All of these are identical. These are all the same. So how many do I have of them? Because I'm just adding them up. I have n of them. So this just means I have n multiplied by how many times I have added them together. Because I have 1, 2, 3, 4, 5, all the way up to n. So I have n of them. So what that means is, okay, the original log b, m raised to the exponent of n is equal to n multiplied by log b to the m. So it's like dropping the exponent in front of the log, right? So anytime you'll have an exponent, you can actually drop it in front, and it comes from this property. And exactly that's what you have on the right-hand side. So that's how you can prove this one. You can actually use that original property to help you. Now, the last property that we have, so for this one, and this is a great property, which is this, okay? So I'm going to copy this. I'm going to bring it down right here. And before proving this, I just want to show you, the power of this. Because very often what you might have is, so I'll give you here an example. You might have something like this. You might have log, okay, raised, to some base. Let's say it was base 3. And then, let's say this was 5.8. So you want to be able to find what log 3, okay, 5.8 is. And what this property tells you is that you can actually change your base. So notice your base here is 3, so this is b, but you can change it to whatever it is that you like. So I called it a in here. Now on your calculators, if you pull up your log, we know that log, okay, the assumption is that it has a base 10. So we can conveniently set this a to base 10. So we can say, oh, I can just change this to log of 10 and say, okay, first number, which is the one inside that bracket, divided by log, okay, of your actual base. So what you're doing is you're switching bases. And this you can certainly calculate on your calculator because this button does exist, right? So you have just changed it to base 10. That's the convenience of this particular property. It's super useful to be able to have it because most calculators won't let you just input any base that you like. Most calculators will have this log, which is assuming that it's base 10. Now, let's try to prove it, okay? Why is this true? So maybe I'm going to kind of repaste it back in here so to clean it up. So I'm going to try to use kind of the trick from property 1 and property 2 that I used. And that trick is, okay, so I'm going to take this right here, and I'm going to call this, okay, and let this equal to x. So meaning what I'm saying is that I have x is equal to log base b to the m. Okay, so that's what I'm calling this. And what I want to show that this, okay, is basically equal to the right-hand side, that I can do that. Okay, so how in the world would I do that? Well, so if you take this, okay, because they're equal, what I can do is I can take the inverse of the exponential, and what that means, okay, right here, is I'm going to rewrite it. So I'm going to rewrite this as saying, so this is just m equal to your base b to the x, okay? So that shouldn't surprise you because these two are equivalent, right? That's what exponentials and logs are. Okay, so I'm just taking the inverse back into an exponential. Okay, great. Now that I have this, I'm going to kind of rewrite it in here. What I'm going to do now is I'm going to take this and, okay, I'm going to now change it. Okay, I'm going to actually apply a log to both sides. So I'm going to take the log, okay, of both sides of the actual numbers. Now, for convenience, I'm going to take the base a right here. I'm going to shift this over. Okay, and I'm going to take the log of a on this side. So this, okay, so I'm taking the log, okay, of base a of both of the sides, which doesn't change the equality in any case. So now with this, okay, so what I notice is that, oh, well, interesting, because in the last property, so this right here, so in the last property, this right here on the right-hand side, so what I have here is that my x is in the exponent, which means I can drop it in front. That's what the other property that I had, so notice that property that we just did right here, that's what this property tells us. So I have here exponent, I'm going to drop it down right there, okay, to get this. So that's what I'm using right here. So I'm dropping that x. But if I drop that x, I'm going to get x, okay, in front there. Now it's being multiplied by log of a to the b. And then on the left-hand side, nothing really changes. So I'm just going to leave it as it is, in that case. And now if I solve for x, so that means I can divide both sides by log of ab, okay, divided by log of ab. So this will cancel because it's just a number. And what does that give me? It gives me x equal to this right here, right? That's what it equals. But hold on, isn't that what the property just told me? Yes, it is. So you can change the base if you like. And it's super convenient to be able to do that for yourself, as I have just shown you on this particular example right there. So that's where it's most useful for. You know, so depending on what base you have, you can always now take, okay, the logs and use this property to help you. Now, if you understood these proofs, then amazing. You know, I will show them to you. You know, they're going to be up there on YouTube. I'm sure that others have done it at some point as well. But it's a nice reference if you ever forget. But the properties, you know, when you're using them, you might remember. So these are the kind of key properties that you have, plus some easier ones right here. And that's what might actually help you, okay, utilizing these. All right, thanks for watching. We'll see you in a future video. Bye, everybody.